Le Chatelier's principle explores the concept of what happens if we do something to perturb a reaction. Remember, everything at equilibrium has reached a situation where the rate of the forward is equal to the rate of the reverse. The concentrations of the reactants aren't changing, the concentrations of the products aren't changing. We've reached a constant, right? Remember, I said we've got this K, we have products over reactants. All right, and this is a constant. So what happens if I do something and I mess with my system at equilibrium? What if I add in a reactant? What if I take out a reactant? What if I add in a product? And so Le Chatelier's principle explores what happens when we start messing with things. All right, so Le Chatelier's principle says if a stress is applied to a reaction mixture, at equilibrium, the reaction occurs in the direction that relieves stress, meaning that the reaction will shift toward one side or the other. Maybe it shifts toward reactants, maybe it shifts toward products, okay? And so if the concentration increases, so if the concentration of one of the components increases, the system needs to consume some of it. All right, and likewise, if the concentration of one of the components decreases, the system needs to produce some of it. Okay? All right, so let's take a look at a system at equilibrium. All right, I've got a reaction here where I've got phosphorus trichloride and chlorine gas, and I get phosphorus pentachloride. Okay, so I've established equilibrium. Now I'm going to do something, okay? I am going to disturb my system. I'm going to add some chlorine gas, okay? Now chlorine is a reactant, so my disturbance so what I'm adding is a reactant or a product. I am adding a reactant. Okay, so I've added that reactant. So what needs to happen here? What does my system need to do? So I have increased the concentration of one of my components, which means my system needs to consume some of it. All right, so if I consume a reactant, I'm going to form more what? I'm going to form more product. And so you can see after it's reestablished equilibrium, did the concentration of my product go up? Yes, it did. So the reaction will shift toward products. Okay, some textbooks and some people like to just think of it as a right to left shift. I like you to think about, are we doing anything to the reactants or to the products? So while you may see, right left as the shifting, I don't want you to just think of it in terms of right left, because then you're just, well, oh, it goes right, oh, it goes left. But what does that mean? Okay, it's going to shift toward products to form more products and consume excess reactant. Because again, we need to get to that ratio, okay? Because for this reaction, our ratio would look like this. Okay, so if I add in more of my chlorine gas, all right, I am increasing that denominator. And so to even it back out, we have to produce more of our numerator. Okay, so we even that back out by shifting in one direction or the other. All right, let's take a look at another system. Okay, so here we've got some nitrogen gas and some hydrogen gas. And we're going to form some ammonia. Okay. All right, so think about this. Okay, before I do any answers, I want you to look at this. What's going to happen, i.e., what direction will this shift? Okay, what direction will the reaction shift? Okay, so I'm going to add in some nitrogen gas. Is that a reactant or a product? It's a reactant. So if I add in a reactant, I have to shift toward products. Okay, all right. Now, what if I add in some more ammonia? Okay, what's ammonia, a reactant or a product? It's a product. So we need to shift toward reactants. Okay, what if I remove some hydrogen gas? I decrease the hydrogen gas. So if I take away some, do I need to reduce the concentration more or do I need to form more? I need to form more. So hydrogen's a reactant, it's going to shift toward reactants. All right, and what if I pull out some of that ammonia? Okay, which direction am I going to shift there? Well, ammonia is a product, and if I take away some, I need to reform more, so we'll shift toward products. Okay. All right, try another one. All right, so we'll figure out what direction we shift toward. And here I have an equation where I've got some oxygen gas and some heat giving me some ozone. Okay, so what happens if I raise the temperature, i.e. I add in heat? Well, I've written heat as a reactant. So if I add in more reactant, I need to shift toward products. Okay, let's take away some oxygen gas. Oxygen gas is a reactant. So if I take some away, I need to shift toward reactants. Hey, what about ozone? I'm going to add in a bunch of that. Well, I'm adding in a product, so I need to shift toward reactants. Okay, and now what about volume? What if I increase the volume? Well, remember we have this PV equals nRT. And we've learned that if we solve for R, we get PV over NT, which means that volume and moles are directly proportional. So if my volume goes up, my moles goes up. Okay, so if volume goes up, we shift toward more. Okay, if my volume goes down, we shift toward less moles of gas. Okay, so when I look here, my reactant side, I have 3 oxygen, so that's 3 moles. When I look at my product side, I have 2 ozone, so that's 2 moles. Okay, heat is not a gas, so that doesn't contribute here. So I'm increasing the volume, and this says that if my volume goes up, I need to shift toward more moles of gas. So where do I have more moles of gas? On the reactant side. So I'm going to shift toward reactants. All right, and that is Le Chatelier's principle.